Hello, everyone. Welcome to the Infrastructure Orchestration to Optimize Testing presentation. It's one of our first presentation in the development track today. It's my pleasure to introduce Rohit Naraparaju. Rohit is a software builds and tools engineer at Intel. He has 8 years of experience in software development. He's an advocate and proponent of DevOps and done several projects in that field. His main focus at Intel is DevOps, infrastructure orchestration, continuous integration, configuration management, automation, and release management. So so today in this presentation, he will talk about the innovations in virtualizations have bring several opportunities and challenges to the testing environment and infrastructure. So he will talk about his experience in the projects he done in the multi-node test environment, in the infrastructure orchestration, and how it can enable continuous integration. So with no further ado, let's welcome Rohit.
Thank you, Amit. Good morning, everybody. My name is Rohit. So this is my first time at PNSQC, and I'm pretty excited about it. So I'm here to talk about the paper which Sajid and I have come up with. That's the infrastructure orchestration to optimize testing. So Amit has already given the bio, but I'll just give about Sajid. Sajid is an engineering manager at Intel Security, and he has about 20 years of experience in the software engineering. He's very passionate about the process automation and product quality. So beginning of this year, we both formed a team that's a DevOps team, and we are trying to bring the DevOps culture within our BU and talking to various teams and trying to understand their aspects and try to automate as much as possible all the aspects and put it as part of the continuous integration and then later extend it to the continuous deliveries. So that's the agenda for our presentation today. To give an overview of our paper in one sentence, so what we are trying to do is how infrastructure orchestration and configuration management like combined together can set up the test infrastructure and configure it automatically and remove all the manual intervention as part of it. So any DevOps engineers here in the room? Or anybody practicing DevOps? Cool. Thanks. So let me give you some introductions. So testing, it's like one of the important aspects of the software development lifecycle, and it helps in improving the product's quality and reliability, and also ensures that a software does what it is supposed to do. So in this new competitive era, a lot of companies are trying to shorten their release cycles from months to weeks and days. And these days I hear that within a day, a lot of companies are even releasing multiple times. So in order to support this, we need to, like product teams are looking at trying to implement smaller feature sets, and these smaller feature sets needs to be tested thoroughly on a different environments, and they need to go under different tests before it makes it to a successful release. So therefore, testing is an important aspect, and it needs to be introduced as soon as they're developed, because fixing a bug at the later stages is very expensive, and it's going to cost a lot to the company. So in order to support testing from initial stages of development, product teams need to start testing them as soon as they're developed, right? So traditionally, like what we used to do is we used to create a lot of pre-created environments, or let's say like fixed environments, and based on the guidelines from the product teams, and have them ready, and then we come and test on that, right? So in order to set up that kind of environment, like depending on the product team's guidelines or requirements, it can take anywhere from a day to a week, or sometimes say a month, depending on how big the infrastructure is. So, and it can delay some significant delay in the testing activities, as well as sometimes can affect the release of the products as well. So what we are trying to do in our paper is we are giving you an overview of the problems which we face with the fixed environments, and how we are trying to solve this problem by going through the infrastructure orchestration, or provisioning the infrastructure using various tools. And what we have done ahead is combine this process as part of our continuous integration tools and test the product right from code check-in and running into your unit test, and then you can spin up a new infrastructure, and you can configure it using the configuration management system, and then you can run your automated test and also send the test results as an email to the interested subscribers. So I'll not go into any details of any of the of our earlier projects, but one of the projects where we were working like a couple of years back, so it's based on the Microsoft Team Foundation server, and we were using the Microsoft Test Manager and the Lab Manager. So here, to set up a single environment, we require about like 2 web servers and a database server. This is a fairly small environment, right? So, but once we have one environment, then we need to like decide on the total number of environments that are required, and also decide on the total computing resources that are required. And then we need to engage a project with IT and establish a workspace in the Team Foundation server. So here we used to do a lot of sys prep manually, like, you have to create a web server, and like before that you need to install the OS, run all your updates. You're basically preparing everything and also configuring the IIS or .NET and like disable some of the firewall settings and everything, right? So it's the same goes with your database server. And then once you have this VMs, you need to kill them and convert them to as a template, right? And then once you have these 2 templates, like the web server template and the database server, you need to create an environment template. And then basically from this environment template is where you are actually creating the environment. And then you log into those environments and change the names of the machines to a meaningful names. And then you take the snapshot. So as long as the infrastructure is small, this is fine. You can manage it. But think about if you're dealing with like 10 VMs that is required for an environment, right? So doing this manual configuration or getting this set up manually is cumbersome. So some of the problems that which we face are like, manual configuration always leads to some of the human error. Like, you configure one VM right, and you might forget some software on the other VM. And later when you're doing some testing, you will see, okay, I missed out something on this testing, right, on this environment configuration. And maintenance of this systems over time, like initially it all works fine, but as you start, the product gets mature, and when you start integrating with other system, that's where it will become very difficult. Like, you need to start configuring your systems with some additional feature set or install a new software that is required and stuff. And the storage limitations. Since we used to take snapshots, they take quite amount of storage on storage capacity on the servers that are assigned as well. And we also needed some dedicated resources, like, you have to manually log into these environments, and then you have to go and install the updates or the product or like some other software. So these were the problems which we usually faced. So considering the problems that we got with the fixed environments, we had to come up with some approach, right? So create the environments at will. So a couple of parameters there are like, like determine if the team will be able to adapt to the new technologies and tools, right? And then next is you need to evaluate a cloud services platform and understand its capabilities, advantages, and licensing and cost. And then you need to choose a right tool, which is the configuration management tool, the infrastructure provisioning, and the continuous integration tool. And again, you need to evaluate them based on your teams, and then, again, understand their support and licensing. So once we have understanding of all these tools, like we need to integrate them as part of some scripting language, and so that, you'll be able to spin up your test infrastructure. So based on the points that I have described in this approach section, I just want to give you a brief introduction to infrastructure orchestration and configuration management. So what is infrastructure orchestration? So basically, orchestration means you're like managing like provisioning and coordinating all the computer services and systems, right? For example, if a team just not only want to spin off a specific server, but they want to install some software on top of it, and configure the database, provision the load balancers, and getting all of these things orchestrated for some testing purpose, and later you can extend it to the production as well. So this is described as like infrastructure orchestration. It addresses the problem of getting all the infrastructure components to work together as you have described in your code or in some structured document. In the computer realm, so it is like it deals with spinning off a specific OS or a custom image and its resources, and getting all the services up and running. So from the developers or testers' point of view, what they're trying to do is they'll just work for the intended purpose and then kill these environments. So therefore, infrastructure orchestration needs to support the assignment and removal of these environments from the shared pool. And a couple of important goals for infrastructure orchestration would be user productivity, managing these resources well, and avoiding conflicts. And some advantages of infrastructure orchestration are like you can spin up multiple environments on a need basis, and you'll reduce a lot of manual effort because once you have all this documented as in your code, you can integrate with your continuous integration tool. So you'll just have the basic infrastructure up, though it's not configured, which we'll talk about the configuration management. And all your testing environments will be pretty much consistent, right? So if you're installing Java 1.8 update 60, so whenever you call this infrastructure script, you'll have the same Java on all the VMs. So let me go to the next one, the configuration management. So what is configuration management? So it's a process that deals with maintaining the software and hardware of a product, right? It records the information about the computer systems and updates that information as needed. So therefore, you can say it's a declarative system for managing the configuration of an instance, right? So typically, what does it do? It deals with starting the services or stopping the services, managing the config files, etc. So basically, this simplifies the engineering effort and understand which programs are installed and which programs needs to be upgraded. So it allows you to describe the infrastructure pieces in a high-level domain-specific language and abstracts the underlying actions being taken. So deployment of these applications and maintaining the infrastructures are pretty delicate and critical tasks, which were earlier managed by hand. So if all these things were managed by some tool, it will save a lot of time, manual effort, and also remove the element of human error, right? So configuration management basically do the detailed work of configuring one or more instances as per their roles, and without any operator specifying the needs to run the exact commands for the instance under test. So some of the advantages are just you can restore the application faster. Like say one of your instances down, you can just get another instance and apply the specific configurations files so that it will be up and running. And it's increased efficiency of configuring the system. You're not touching it, you're just doing it automatically, so it will increase, and cost savings. So let me go to the next, the infrastructure orchestration workflow diagram which we have come up with. So this is limited to only the testing infrastructure. So you have your dev workstation where you'll write your infrastructure provisioning scripts and the configuration management scripts, and then you check them into the source control. And then the continuous integration tool will check for any new build or any new changes that's there in the source control, and then later it will trigger the compile build. And once the build is successful, it will copy the output to the build repository. And then we upload the configuration scripts to the configuration management server. And the continuous integration tool then later kicks off a deployment build as well. So this deployment build actually first spins up your infrastructure, and then it will apply the configuration management scripts to get the infrastructure to a desired state. So based on the approach, I wanted to give you a small, we have classified the tools in 4 categories. So that's cloud services platform, infrastructure provisioning tools, configuration management tools, and the continuous integration tools. So here I'm not judging any tool or giving any verdict on saying which tool is better. I just wanted to give you a brief overview of the tools that are available in the same workspace. So for the cloud services platform, it's like Amazon Web Services or the Microsoft Azure and the VMware vCloud Virtual Private Cloud. So the third one is something which we are using in our solution right now, as it is hosted by one of the teams, and they expose their commands like CLI commands as well as the GUI where we can request VMs, reconfigure the VMs, and you can destroy, shut down, or do a couple of other tasks out there. Like Amazon and Microsoft Azure, they are like the public clouds. So here the good part is you don't need to invest in your hardware upfront. You just use whatever services you want there, and you pay for whatever you use. And they can also scale up and scale down depending on the computing resources that you have in those services platforms. So a couple of advantages, like before going to advantages, the features, like benefits of using this are like they not only provide the resources, but they have some analytics and they have some monitoring and logging tools well integrated with that, so which you can use again, and then you pay for whatever you're using there. And advantages are it's like easy to start, inexpensive, like you just go and pay for the services that you use, and they're really reliable and secure. So the next part is the infrastructure provisioning tools. So a couple of examples here are the Terraform, AWS CloudFormation, and the VMware vRealize automation. So the VMware vRealization automation is pretty tightly coupled with the cloud service, which is the virtual private cloud from the VMware. And Terraform is a tool to build, change, and version the infrastructure components like networks and your instances pretty efficiently and secure way. So it can manage the existing service providers as well as the custom in-house built service providers. That means Terraform, you can write your plugins and you can bring up the infrastructure. You can write your infrastructure scripts. And it's very well integrated with AWS and the Microsoft Azure. They have the plugins for the AWS and Microsoft Azure. So Terraform actually uses a declarative languages that describes the resource components need to be used. And the big advantage of Terraform here is it's cloud agnostic. And you can combine multiple services and providers as well here. So configuration tool tells the Terraform script to bring the infrastructure to some desired state, right? So like you just spin off your VM and then you ask it to, put it behind a load balancer or configure within some security group and etc. like that. So AWS is, the next is the AWS Cloud Formation, which is native to AWS resources. And the good advantage of AWS Cloud Formation is there are already a lot of sample templates that are available, which we can readily use, or you can write always your own templates, and you can save them and use it for your later scripts. So one good advantage of both Terraform and AWS Cloud Formation are that you don't need to worry about the provisioning order. It's been taken care by those two tools itself. And VMware vRealization automation, as I told you, it's a bit tightly coupled with the cloud service platform which we're using. So it's designed to improve the deployment, application management, personalized infrastructure, and compute resources. So it's a cloud, it's a software for unified cloud management that helps the administrator to configure and provision the database and networks for your cloud. So the next is configuration management tools. So some of the examples here are Chef, Puppet, and Ansible, and you have a lot of other tools. I didn't want to go through all the tools, just wanted to give the most popular, which at least I came across through. So Chef is a Ruby-based configuration management tool, and it is available as a free open source or as a paid subscription. And it utilizes this master agent communication. So basically, apart from this, you will have a master server, and then you have a lot of clients configured, which talks to the Chef server. And the Chef client is installed on all these nodes, where it will pull the latest configuration files from your Chef server, and then it will run those configuration on those respective nodes, and it brings them to the desired state. And Puppet is also similar to Chef. Like, I won't say exactly similar, but it's also Ruby-based management tool, and it also has agents which talk to the Puppet server and downloads the modules and bring the infrastructure to the desired state. And Ansible is pretty new when compared to Chef and Puppet, but it's an agentless tool which communicates over secure shell and try to bring the configuration management and also add some better security as well. And the modules in Ansible are called as playbooks, and it is very easy to learn and write because it's in a YAML format. So some of the features are it's like ease of use and automate the machine configuration and efficiency. Coming to the continuous integration tools, so Jenkins and TeamCity are the most popular here. So and both have very easy to set up, and they have well documented, and it's easy to use. And the good part is you have a lot of plugins which you can use. And TeamCity comes with some of the inbuilt dashboards and reports. And Jenkins, since it's an open source, we can also contribute and write your own plugins as well. So let's come to our solution, and how we are using this. So basically, in one of our projects, we started using the big data platform technologies. And usually to set up any environment for big data platform, it requires a huge test infrastructure to have your application up and running. So the main intent of that project was to store different kinds of threat events that are coming from the McAfee agent into the scalable distributed database and move away from the infrastructure, from the Microsoft SQL Server. So in this project, we had to use the Cloudera distribution, including the Apache Hadoop platform, which provides Apache Hadoop-based software services and support. It's an open source framework, and it's very useful, and it's good for, and it's basically reliable and used for distributed processing. So one of the advantages of this CDS platform is it can, like these technologies, you can scale up from one node to like thousands of nodes, and they offer services like, and it will handle the failovers and offers local computation, and they're pretty highly reliable. So Cloudera has numerous products in the offering, so we just selected a handful of them which are required for our solution. And based on this, we had to come up with some infrastructure. So to set up our infrastructure, like a test infrastructure, we required about 12 VMs. And each VM, the configuration spec is pretty high. Like it requires like really high RAM, the larger disk storage, and the CPU cores. Consider if I'm going through this as the traditional way where I have to create this manually, right? So it's like 12 VMs, and then later this need to talk to each other as well, right? So if I miss on any configuration, I'll spend a lot of time debugging, like where am I going wrong? But if and we didn't want to go through that approach. And if we actually go through that approach, I'll spend up like a couple of days just to set up the environment. Once I set up the environment, then I'll have to test that or validate that environment, which can take anywhere from a week or close to a month as well. And you're basically halting all your testing activities, right? So you're not even doing any testing. So we wanted to follow a different approach here. So that's where we introduced the tools. So the tools that which we're using are the in-house VMware, vCloud Virtual Private Cloud, the Chef for the configuration management, Jenkins for the continuous integration, and the VRA for provisioning the infrastructure, and the Python script which bundles basically all this API calls, the bootstrap commands, and run the automated test. And then steps for setting up this are like, as part of the continuous integration is you need to create a job in Jenkins, right, for creating the infrastructure. Then you write the Chef cookbooks, and like this is, since we are using Chef, it's the configuration files are managed as part of the cookbooks, and then you check into the source control. And then you write a Python script for provisioning the VMs using the VRA APIs and bootstrapping the Chef commands and bringing the infrastructure to some desired state. Then you check in the Python script to the source control, and then you configure the Jenkins job to run this Python script, which will provision your infrastructure, configure the infrastructure, and run your automated tests. And then one other step, what we have done is we configured a post-build deployment in Jenkins, so which will publish your test results as an email to the interested subscribers. And to give a basic layout of a Python script, it reads the VM configurations from the config file. It will call the VRA APIs exposed by the cloud services platform. Then it will check the provisioning status of the VMs, whether it is passed or like it has failed or so. And then it will store the results of the provision file in a JSON file. And finally, we call the Chef bootstrap commands to configure the respective application. So some of the benefits here. So earlier, when we were trying to set up this environment manually, we used to take about a day and then another couple of days to get it up and running fine. But by doing this, we were able to set up like less than 2 hours. And in that 2 hours, we're also running some tests, right? So we are running about like close to 150 tests as part of it. And here, there's no manual intervention. So you can spin up any environments you want here, any number of environments, and you can run multiple builds, and you can perform multiple, you can run different kinds of tests on those environments as well. And here, you can change the configuration of these environments by passing like the configurations in one of the files. Like if you started off with like say 16 gigs of RAM for one environment, and if you want like 32 gigs of RAM, so you can just mention all this in one of the configuration file and pass it as one of the parameters. So one of the benefits what we do is like how it affected us, or like in a very successful way is, so every week, our team, what we do is we create a new environment. Like our team comes together, and then we do a lot of exploratory testing and find all the bugs, and then we assign those bugs to each member in the team and try to automate them and put it as part of this process. And in this way, we are running this builds multiple times a day, and we know which tests are passing and which tests are failing. And based on this, like if any of the test fails, we are going and fixing them as soon as possible. So basically, we want to keep this pipeline passing all the time. And before I go to questions, so some of the future work is this is very limited to testing infrastructure. It's very rudimentary. We want to extend this to like a larger infrastructure where we want to involve the load balancers and put them in some private and public subnets and make it more secure. So that's a work in progress, and hopefully we want to extend this later to the continuous delivery pipeline and also extend it to the production as well. Yeah, that's pretty much from my side. Any questions? Sure. Go ahead.
So you mentioned wanting to go to the load balancer. So where's the load on your infrastructure?
Sorry, can you repeat the question?
You mentioned wanting to introduce load balancers.
Mm-hmm.
Where's the load on your infrastructure? Like, so, for example, in our infrastructure,
Mm-hmm.
the load is in the cloud, not in the access to the cloud.
Okay.
So what is your need for a load balancer?
So we are exploring some public cloud platforms like, say, AWS and Azure. So we want to create the load balancers there so that it will hit that load balancer first and then distribute the traffic to respective VMs. So that's something which Amazon does right now, right? So we wanted to start introducing those load balancers there and then configure some rules saying like if it hits this 443 port, resolve it to internally some different ports and redirect the traffic to it. Did that answer your question?
No. So in your use of the infrastructure, so are you saying that you'll have your test team will say, I just need it, and the load balancer will say, well, there's...
Currently, we are not dealing with any load balancers. It's just one specific.
Future.
Yeah.
10 testers are going to say, I want test environment, and then the load balancer determines, envisions that.
So yeah. So basically, we create load balancer for each environment. It's not that all the 10 environments will be listening on the same load balancer. So as part of each infrastructure that we create, we want to keep it isolated from the other infrastructure. So we are creating all the resources that are required, like including the security groups and the load balancers, and keep it pertaining to that particular environment. So it's not going to be like all the environments are talking to the same load balancer. Yeah. Sorry, somebody else has a question. Yeah.
So VMware, I think, recently got put up publicly on AWS. Do you anticipate using something like that?
Too early to comment anything on that. So we are still in the exploring phases, and yeah, we wanted to, because we had some limitations with the existing cloud services platform, right? What we are using, and we are trying to see if we can work with the existing team, whoever's hosting that, and try to see if we can use that or maybe move to some public cloud platforms. So this we had to use because we wanted to get this product up and running quickly, so we wanted to use whatever is available there rather than inventing something from us.
What limitations are you seeing?
Right now here, we don't have, like, we cannot create the load balancers by our own right now, right? So, and if we have to create the load balancers, it's some IT team that's doing it, and they're hard coding those values and giving it to us, so which we don't want it. So we want to keep every environment very much isolated and try to do our testing. Yeah.
Do you have any interaction with the database with the product? And if so, do you see that these individual environments will share that same database, or each spin up their own instance?
It's basically independent, right? So it's going to spin up its own database as well. So since it's only testing infrastructure, we are doing this, like spinning up everything for that
Do you
infrastructure.
populate that with some sort of known test data?
Yeah, that we can put it as part of one of the Python scripts or some other scripts as continuous. Sure.
What's your approach to being able to use everything that you put together, whether it's in the cloud, whether it's in Azure, AWS, or a local VMware instance, like with network paths, credentials? What's your approach there?
So we started exploring the Terraform there. So we write everything as part of a modules, and you can create some credentials files over there, which the Terraform will read and set up the infrastructure. And if it is anything related to configuration, we use a chef and like the data bags where you can encrypt your passwords and everything. And then when you're actually bringing up that instance, it will use some internal decoders and then get this up and running for you. So, yeah. Any other questions? Yeah.
So what's the size? Like how big is this? How many people? Maybe say at the beginning, but how large is this infrastructure?
So initially we started off like with 12 VMs, and then we scaled down to like 6 because when we are trying to give this infrastructure to some other team, like they cannot afford this kind of VMs and the compute power, right? So we deal with two ways. Like one is like if you're giving to any external teams, we just give it like a very base minimum, which is 6 VMs. But again, the compute power is like about 32 gigs RAM and about 300 gigs of database and 16 cores of CPU. But if it is like 12 VMs, then we deal with like 8 cores and for few nodes, it's like 16 gigs, and few nodes we have to go with 32 gigs. And then the disk size will vary again depending on the nodes. So in our thing, we run like a nightly loop where we bring up this 12 node infrastructure. But if it is something on for each build, we try to maintain it like to a minimum thing and make sure that the tests are passing.
This example, was this a single instance, like a 12-node instance? Is there multiples of those?
It's each, like 12 node means like there are 12 VMs there.
How many of those do you have? How many 12 node do you have? How many?
So the way we do it is we do the test and we kill it. And then whenever we want it, we bring up a new one. So we are not keeping anything overnight there, unless it is, if you have to debug something. Yeah. Yes.
So what was the deciding factors between Chef and Puppet?
Somebody in the team already had this knowledge, and like we said, we have to get this up and running quickly, so we had to use that. Yes, there was a lot of debate, Chef or Puppet, and had some tug of words with the IT, but then it was, at the end, we decided, let's go with Chef. And yeah.
Windows, Unix?
Both, actually, Linux. And we started off with Linux, but now we are supporting and with the Windows as well. And we can bring up in combination as well. Any other questions? Okay, thank you. And that's our contact info. So if you have any questions, you can mail us to